Hello, this is the luckiest maths teacher in the world, and today we're going to review some of the concepts in geometry that may come up in later lessons. So our whole goal here is that we want to be able to prove things using similar triangles and congruent triangles. But there's a few things that might come up, and it's really important that you know them before we continue. So there are three things I'm going to go through in this video. The first is angles and parallel lines. So this includes alternate angles, corresponding angles, co-interior angles, and so on. The second thing I'm going to go through is types of triangles, and the third thing is types of quadrilaterals. And if you don't know what a quadrilateral is, it's just a four-sided shape, okay? So feel free to skip to any particular part of this video if you think you've got any of these three covered. So all of these three things may come up when we're looking at congruent or similar triangles. Alright, so let's get into it. We'll start with angles and parallel lines. So we'll start off with angles and parallel lines. So firstly, we note that parallel lines are lines that will never meet no matter how long they went on, and they're usually given a little arrow like this to show that they're parallel. Okay, so the types of angles that we're looking at. So first off, we'll go through these two types of angles are called vertically opposite, okay? So that's because the blue dot plus the black X, those two angles here, they're supplementary, so they must add to 180 degrees. So blue plus X equals 180 degrees, right? But same, these two angles here, X and the blue dot, must add to 180 because they're supplementary. So that means that this angle here and this angle here must be equal. Similarly, because this and this add to 180, but also this and this add to 180, this angle here is also equal to the one opposite it. So vertically opposite angles are equal. So that's the first point that we need to know. The next type of angle that I'm going to go through is alternate angles. So they make a Z shape like this, but it can also be a back to front Z shape like this. So this angle and this angle marked in red, they are both alternate, and this angle marked in blue, they are alternate as well. And alternate angles are equal. So that's the second type of angle that we've learnt about. So alternate angles which make the Z shape are equal to each other. So let's get rid of this and look at the next type of angle. So the next type of angle I'm going to look at is corresponding angle. So corresponding angles make an F shape like this, and so they're in and out of the F, but it can be an upside down F. So for example, this one here can be upside down, and then this angle, this angle here and this angle here are corresponding, okay? So they're also equal. So that's the third type of angle we learned about. Okay, so I've just written it there for you. Corresponding angles which make the F shape, they are also equal. Okay, so there's one more type of angle that we need to go through, and that's co-interior angles. Now, co-interior angles are a little different because they are not actually equal. So co-interior make a C shape like this. So they're co-interior, they're on the same side of the parallel lines. So these two angles in red are co-interior. Can also make a back to front C shape. This angle and this angle are co-interior. Now you can see from the picture very clearly that the two blue angles are not equal to each other and the two red angles are not equal to each other because one of the red angles is obtuse, one of the red angles is acute, and same for the blue. So this one's a little harder, so I'll write it in a different colour. So I'll write it up here. So for co-interior angles which make the C shape, they are supplementary. This angle and this angle add to 180. Okay, so I'm just going to put they are sup for short. They add to 180. Hopefully none of this is new and it's just review. So let's just do a quick example with some actual numbers. Okay, so I've given you one angle that's 118 degrees, and I'm going to go ahead and find out what A, B, C, and D are. Okay, so first off, we can find A easily. A is 118 degrees. Now, when we're doing questions like this, we have to give a reason. So I'm just going to abbreviate it as vertically opposite. Those two angles, A and 118, are vertically opposite, therefore they are equal. Next, I'm going to find B. So I know that A and B must add up to 180 because they are co-interior. They make the C shape like this, right? So B plus A equals 180 degrees. So B is just 180 minus 118, which is 62 degrees. Again, I'm going to give a reason, and the reason is co-interior angles. Okay? Now C, I could find it a few ways. It's supplementary to B, or I can say that it must equal A, which is 118 degrees, because it's actually alternate, because they make the Z shape. Okay, and the last one, D, again, a few ways I could calculate it. It's corresponding to A, it is vertically opposite C, and it is supplementary to B. Either way you go is fine, as long as you have a reason. So I'm going to write that D is 118 degrees also, and it's corresponding, because D and A make the F shape like this. Okay, so that's all for angles and parallel lines. Now I'm just going to quickly go through the types of triangles. Oh yeah, so please copy this down if you need. Okay, so we'll go through types of triangles. So this image, which I got from learnhive.com, shows it very, very well. So we can classify triangles in two ways, based on the number of equal sides that we have here, and based on the angle properties that we have here. So each triangle will be one of these and one of these. So in a triangle, the number of equal sides is always equal to the number of equal angles. Okay, so a scalene triangle has all its sides different, but if a triangle also has its angles all different, then it is scalene. So isosceles triangles, they have two sides equal, and the converse is true as well. If a triangle has two sides equal, then it's isosceles. But having two sides equal also means that it'll have two angles equal. And if it has two angles equal, it'll have two sides equal. And equilateral just means all sides and angles are equal. So each triangle will be one of those. Now, we call the triangle acute if all its angles are acute. Now, remember that a triangle can have three acute angles. It can only have one right angle at most, or it can have at most one obtuse angle. So if it does have that one right angle, then we call it right-angled triangle. If it has one obtuse angle, we call it obtuse-angled. Remember, of course, if it had more than one right angle or obtuse angle, then the angles inside it wouldn't add to 180. And we know that, I'm sure. So the angle sum of a triangle is 180. Always 180. Doesn't matter if it's the weirdest looking triangle ever, it's always 180. Alright, so let's just do one quick problem to see how we're going. So let's have a go at this question. So a triangle has one angle equal to 20 degrees and one angle equal to 80 degrees. What type of triangle is it? Now I just told you that the angle sum of a triangle is 180. So that means that the third angle in this triangle will be 180 minus 80 minus 20. So you're figuring out how much more you need to get to 180. So 180 minus 80 is 100, minus 20 is 80 degrees. Okay, so this is a triangle that has two angles equal to 80 and one angle equal to 20. So because it has two angles equal, but not three angles equal, then it will also have two sides equal, and it will be an isosceles triangle. So that's the side property of it. But what type of angle is it? Is it obtuse angled or acute angled? Well, we can see that 80, 20, and 80 are all acute angles. So we call this an acute isosceles or an acute angled isosceles triangle. Okay? So what you need this for is when we're doing things involving similar triangles or congruent triangles, you will need the properties of isosceles triangles or scalene triangles sometimes, or equilateral triangles to prove that two triangles are congruent or similar or whatever. So we just need this in the back of our minds for subsequent lessons. Alright, I'm going to do now quadrilaterals, and that will be the last thing for today. So again, please copy this down if you like it. Okay, so just so we're clear, a quadrilateral is any four-sided shape, no matter how weird it looks, just like a triangle is any three-sided shape. Okay, so there are obviously different types of quadrilaterals, and you know a lot of them. So, for example, you know that this one here, I know I'm not the best drawer, so this one here, if it has one pair of parallel sides, we call it a trapezium. Okay, so if it has two pairs of parallel sides, it's a parallelogram. So you probably already know this. What you may not know, though, is that any four-sided shape that has two pairs of parallel sides is a parallelogram. So that means that a rhombus is a type of parallelogram because it has two pairs of parallel sides. Now, a rhombus is just a special type of parallelogram where all of the sides are equal. A rectangle is a type of parallelogram. It's a special type of parallelogram where all angles are equal. Now, because for any quadrilateral, the angle sum is 360 degrees, that's because you can divide them into two triangles. So I'll try that with the trapezium. So trapezium, I could do two triangles, parallelogram, two triangles, and each of these is 180. The angle sum is 360. So what that means is if all angles are equal, then all four of them will be 360 divided 4, which is 90 degrees. So a rectangle is a special type of parallelogram in which all angles are 90 degrees. Now a square fits both the definitions I've just given you. A square is a type of rhombus because all sides are equal, but it's also a type of rectangle because all its angles are equal. So that's the thing you may not know. A square is a type of rhombus, it is a special type of rectangle as well, and therefore it is also a type of parallelogram. Now, a rhombus is also a type of kite. But a kite is not a parallelogram, it's not a rectangle or anything like that. A kite is a special type of shape, it's also called a diamond, where it doesn't have any parallel sides, but its adjacent sides are equal. Okay, in a parallelogram, opposite sides are equal in length. But in a kite, adjacent sides are equal. Okay, so I'm just going to go through one problem again, and then we're done. So we're going to have a go at this question. Explain why all squares are rhombuses, but not all rhombuses are squares. So it's not so much that I really want you to know the ins and outs of all these types of quadrilaterals. It's just so doing this lesson, you will have at the back of your minds the properties of quadrilaterals. So if you have to do a congruent triangle involving, say, dividing up a parallelogram, you'll know its properties well enough that you'll just be able to solve that no problem. Okay, so let's go through it. So this is two parts of the question. Explain why all squares are rhombuses. So we'll do that first, and then we'll explain why not all rhombuses are squares. So I've just given you the answer to that. So a square is a rhombus because a square has all four sides equal, and it's also a parallelogram. Okay, so that says what I just said. Square's a rhombus because it is a parallelogram with four equal sides. So every shape that is a square is also a rhombus. So that's sort of the first part of it. Now let's do the second part of it. So we're going to explain why not all rhombuses are squares. So to do that, we just need to think, what does squares have that not all rhombuses have? I mean, squares have four equal sides, but all rhombuses have that. What else do we know about a square? We know that it has four equal angles, but not all rhombuses have that property. So that's our answer. Alright, and the second part is here pretty much what I was going through. So a rhombus is not necessarily a square because it doesn't necessarily have four equal angles. And the very astute of you will know that what I said for triangles, where number of sides equals, number of equal sides equals number of equal angles, that doesn't hold for quadrilaterals. So in quadrilaterals, it isn't true always that the number of equal sides equals the number of equal angles. Sorry for the long video. Hope you found it informative. This has been the luckiest maths teacher in the world. Have a great day.